Okay. Good morning, everyone. Good morning, Aryan. Morning, Arya. Yes. Okay. So everyone remember what we have studied in last class. Okay. So this is the second class of ionic equilibrium, right? In last class, we studied about the basic terminology, right? What is your electrolyte? What is strong electrolyte? What is weak electrolyte? Then the types of electrolytes, acid, base, and salt. Then what is strong acid? What is weak base, weak acid? Okay, right, everyone? And we started with Arrhenius theory, right? Okay, okay, everyone. Now, before starting the class, right, let's have some recall test. Okay, now tell me. First one, electrolyte that ionize completely on dissociation or dissolution of water are very good. Very good, everyone. Right? So many of you are saying strong. Okay, very good. Second, acetic acid as is an example of dash electrolyte. Yes, very good. Very good, Akshay. Very good, Anisha, Soumya, Siddharth. Very good. Weak. Okay. Basis taste. This is super easy question. We have studied since class 7. Yes, very good. Bitter. Fourth, strong acid have dash conjugate base. Tell me. Yes, very good, everyone. Weak conjugate base. Very good. Okay. Fifth one, the pH of pure water at room temperature is, yes, very good, 7. Okay, so this was fairly easy, right? Okay, very good, Shreya. Very good, Kushi. Very good, Sneha. Okay. Now, so we have studied till this point, right? What was the behavior of acid and base in solution? Now, when we talk about behavior, right? We talk about dissolution. We talk about what ions they'll form, right? How H plus will exist as H3O plus, right? And all those things. Okay. I hope everyone remember these things, right? Okay, the most important thing that we studied in last class was about conjugate acid and conjugate base, right, everyone? Conjugate acid and conjugate base. Okay, now if you remember the concept of chemical equilibrium plus chemical bonding. So I hope all of you remember the concept of chemical bonding, that higher the oxidation state, right, acidic strength related with oxidation state. Okay, for example, see this. We have three acid over here, right? HClO4, HCl, and HNO3. Out of these three acids, right, you have said that, okay, this acid is stronger than HCl, is stronger than HNO3. Okay, what does that mean? That means if a stronger acid can release more H plus, right, then obviously it will be stronger. An acid which releases more H plus will be stronger. How can we find that an acid is stronger or weak? Right, we will form their conjugate base. For example, for HCl4 we will get ClO4 minus. For HCl we'll get Cl minus. For HNO3 we'll get NO3 minus. Right, then we will check the stability of these three. Okay, stability of these three, right? Okay, or what is meaning of stability? Means electron giving tendency. Okay, if the electron giving tendency of an ion is less, means it is more stable. Yes or no? Tell me. Yes or no? Right, right, everyone? Okay, okay. Anyways, we will study this in detail in organic, no issues in that. Okay, we don't have to bother about that in this chapter. Now, okay, so this till this point we have studied in last class, right? Till this point we have studied in last class. Okay, so if we make a mind map, right? Just make a mind map. If we make a mind map, of what we have studied, right, or what we have to study, right, then we can make a mind map like this. So we have electrolyte. Everyone just focus here. We have electrolyte. Electrolyte, right? Electrolyte can be divided into two types, right? Let's see. It is the revision of mind map that we have already studied. Strong and weak, right, everyone? Strong and weak. Very good. Now, in strong also, we have three different type of electrolytes, and weak also we have three different type of electrolytes, right? They're acid, base, and salt. And this also acid, base, and salt. Got it? So I can say that I have to study these kind of electrolytes. Okay, right? Now, we know that strong acid, right? Strong base or strong salt are salt because they dissociates completely, right? Right? So I can write that alpha is almost equal to 1. Okay, now if alpha is almost equal to 1, which means it dissociates completely, no equilibrium concept is involved, no equilibrium. Right, everyone? No equilibrium. So we don't have to think about equilibrium for this strong cases, right? In weak, alpha is less than 1, right? So equilibrium is involved, right? Got it? Any issues? So that is how you should approach any concept. Okay. So first, what you have to find, suppose you have any problem, right? Suppose you have a problem, you have to see what is your component, what is your reactant. Either it is strong electrolyte or weak electrolyte. You should not start solving without thinking about the nature of electrolyte. That's the first thing. If it's strong, right, it will dissociate completely. No concept of equilibrium will be involved. Okay. But if it is weak, then you have to think that it is okay, it is either acid or base or salt, right? Okay, everyone, tell me. Okay, anyone have any issue in this? No? Okay, very good, everyone. Now, let's see. Now, when we talk about weak electrolytes, let's see weak electrolytes one by one. Weak electrolytes. Okay, step by step. Okay, step by step. Now, when we talk about weak electrolyte, the first we studied was weak acid. Weak monobasic acid. Monobasic acid. Okay. So what's the meaning of weak monobasic acid? It is your HA. HA. Right. Now we know that for HA, it will dissociate into H plus plus A minus. We have already done this. Yes or no? Tell me, everyone. Yes or no? Right. So initially, if it is C 0 0, same. Use the concept of chemical equilibrium. Right. Use the concept of chemical equilibrium. Okay. Just think about it. Use the concept of chemical equilibrium. So I can say that at if the degree of dissociation is alpha, degree of dissociation is alpha. So at equilibrium, we'll have C minus C alpha, C alpha, C alpha. Got it? Now, according to definition, Kc, which is equal to Ka here, because it is your what? Right? Acid. Okay. Now, in many places we will have H2O plus HA, okay, right? Okay, but since H2 is pure liquid, H2 is pure liquid, right, you will take as 1, or you can just write like this, Kc into H2A, H2O is equal to concentration of right? H plus, A minus. Wait, I'll just write each and every step, okay? Into H2O. So I'll write each and every step divided by concentration of HA. Yes, everyone? So Kc into concentration of H2O. Since this is 1, right? We usually write it as Ka. Okay, everyone? So K is this concentration of H plus into concentration of A minus by concentration of HA. That's it. Right, everyone? Anyone have any issues? Tell me, anyone have any issues till this point? No? Okay. So this can be written as C alpha whole square by C bracket 1 minus alpha. That we have already studied in last class. Now we know that if alpha is very less than 1, if alpha is less than 1, right, we can neglect alpha. So we will get C alpha square because CC will get cancelled and 1 minus alpha will be neglected, right? So if you see this, right, we will get alpha is equal to root Ka upon C. Tell me, yes, everyone, right? Yes. No one have any issues in such? Now, what you have to find here, you have to find concentration of H plus, right? You have to find concentration of H plus. So tell me, what is the concentration of H plus? Tell me, everyone, what is the concentration of H plus? Tell me, everyone. It is nothing but C alpha, right? C alpha. Okay. Now, if we put the value of alpha over here, we will get what? C root K upon C. Okay. Now, this is equal to root Ka into C. Yes or no? Yes or no? And this is called your, we have already studied what is Oswald law of dilution, right? The degree of dissociation is directly proportional to volume or in directly proportional to square root of volume or inversely proportional to concentration, square root of concentration. Okay. So this is your concentration of H plus. Anyone have any issue in this? Tell me, everyone. Anyone have any issue till this point? Just raise your hand. If you have any issues, message me, otherwise raise your hand. Okay. Okay, everyone. Right, very good. Sneha, C is root C into root C. So one root C is cancelled, right? Got it? So root C into root K is root K into C. Okay. Okay. Everyone, Mansi, Samya, right? Imba, Jasharan, Koshi, Anamika, Riya, Shreya, everyone is getting. Vivek, Jitendra, Siddharth, Maulik, Meet. Okay, very good, everyone. Right? Very good. Okay. Now, if you remember, right, there's a term called pH. There's a term called pH. Okay, right? So what's the pH? Or you just write as like this, pH. So pH is nothing but minus log of concentration of H plus. Okay, this is the definition of pH. Okay, everyone? Yes, it is power of H. It is called as power of H. Okay, right? Now, when we talk about this formula, right? Now tell me, what is the pH for weak acid? So it will be just pH is equal to minus log. Now, what is concentration of H plus? This one, yes or no? Tell me, everyone. So can I just write like this, root Ka into C? Yes? Yes, everyone? Okay, right? Now we know the properties of logarithm. Okay, what are the properties of logarithm? Right? We have log x to power m is equal to m log x. M log x. This is what property. Okay, this is your property, right? So I can write like this. minus half log Ka plus log K plus log C. Yes or no? Tell me. Because log A into B is equal to log A plus log B. This is also one property. Bio students, everyone remember bio students, right? So we use two properties over here. First property, log x to power n is equal to n log x. And second property, log A into B, A into B is equal to log A plus log B. These are the two properties, okay? Right? Right? Imba, Suhas, Anamika, got it? These are the two properties, okay? Now we should, I'll just rub these. Now think about it, right? Now think about it. As we said that pH is equal to minus log of concentration of H plus. So I'll just take this minus inside. So we'll have half minus log of Ka, right? Base is 10, okay? Base is 10 minus log C. Got it, everyone? Tell me. Now this term minus log of Ka is called as pKa. This is called as pKa. Okay. Minus log of K is pKa minus log C. Tell me, everyone, anyone have any issue in this? Tell me everyone, anyone have any issue in this? So this is pH of what? pH of weak acid, right? For weak acid. For weak monobasic acid. Monobasic acid, pH is equal to this. Right, everyone? Okay, right? So everyone got this concept, yes or no? Everyone got this concept? Now, answer me this. Can I use this formula all the time, or is there some limitation? Tell me. Can I use this formula all the time, or is there some limitation? Think about it. Yeah, even for weak acid, right? This can only be used when alpha is very, very less than 1. As simple as that. Okay? Right? So we have to use this formula only when alpha is very, very less than 1 for weak monobasic acid. As simple as that. Got it? Tell me, got it? Okay. Now, let's think about second type of electrolyte. Okay. Second type of electrolyte is weak monoacidic base. Monoacidic base. Okay. So it's like BOH. Okay. BOH gives B plus OH minus C00, right? Now please try to find, okay, pH, or see if pH is equal to minus log concentration of H plus, then POH should be minus log concentration of OH minus. Got it? Right? Then pKa is minus log concentration, it's just Ka. And pKb will be same as minus log Kb. Okay? Got it? So these are the terms that you have to use. Now try to find POH, because we have OH minus furnished over here, right? So first try to find POH for this reaction. Okay, can you do that, everyone? Tell me, can you do that? Okay, let's see, right? So I guess most of you might have solved. We'll just proceed in the same way as we did in weak base. Okay, sorry, weak acid. So we will have C minus C alpha, C alpha, C alpha. If you see that, right, every step should be same. So it will be Kb is equal to concentration of H plus, sorry, not H plus, right? My bad, B plus into concentration of OH minus. We will start with this always, concentration of BOH. Now this will be C alpha squared by 1 minus alpha. Again, same thing. If alpha is very less than 1, right? Which is alpha should be less than what? Tell me, should be less than 0.05 usually, right? But you can use for higher values also, doesn't matter. Okay, it should not be like 0.5 or 0.4, 0.3. It should not be like this. It should be less than that. Now, this will become what? Tell me. This will become C alpha square. So Kb will be C alpha square. In the same way, alpha will become root of Kb by C. Right? If you observe, right, it is same statement. Yes or no? Tell me. Right? Instead of K, Kb is there. Right, everyone? Tell me. Just raise your hand. Yes? Isn't it the same statement? Okay. Now, concentration of OH minus. Concentration of OH minus is equal to what? Just C into alpha, which is C into root Kb divided by C. So again, it is root Kb into C, right? Now we will just use the same concept. You'll just same POH. This is equal to what? Minus log concentration of OH minus. Okay, right? So if you just use the value, right? Use the OH minus formula as root Kb into concentration of C, you will get half minus log Kb minus log C, which in turn will give you half pKb minus log C. Right, everyone? Tell me, right? Now tell me, isn't it the same formula as pH? Yes or no? Tell me, everyone, yes or no? Okay, very good, everyone. Very good, right? Okay, now you should ask, okay, so this is POH. Now there's one question of students, so that if we have base, will it not contain H plus? Or if we have acid, will it not contain OH minus? Now, see, all these reactions are happening in water. Okay, so there will be H plus and OH minus, right? There will be H plus and OH minus. But what happens here? Let's see. When we talk about water, H2O. So H2O is in equilibrium with H plus plus OH minus ion. Okay, got it? Now you can just write same thing for OH. So Kc is equal to concentration of H plus into concentration of OH minus divided by concentration of H2O. But we know that H2O is a pure liquid, so I'll just write like this. Kc into concentration of H2O is equal to concentration of H plus into concentration of OH minus. Got it, everyone? Tell me, got it? Now, this is written as Kw. This is written as Kw. And what is this? This is nothing but the product of ions of water, right? The product of ions of water. So it is called as ionic product of water. Ionic product of water. Got it? So Kw is called as ionic product of water, and it is fixed because we know that Ka, Kb, K, everything is K, which is fixed at constant temperature. So this is fixed. The value of this is fixed, which is 10 to the power minus 14. 10 to the power minus 14. So the value of Kw at room temperature is 10 to the power minus 14. Okay, everyone? Tell me, okay, everyone? Yes or no? Yes or no? So let's give the heading ionic product of water. Okay, got it, right? Now just think about this. Case 1. Case 1. Neutral solution. Neutral, right? What do you mean by neutral? Neutral means concentration of H plus should be equal to concentration of OH minus. Tell me yes or no. Yes or no, right? Yes. Okay, now let's see. Using this, can I write like this? Concentration of H plus into concentration of OH minus can also be written as concentration of H plus. This is equal to 10 to the power minus 14, right? Which will give me concentration of H plus as 10 to the power minus 7. Yes or no? Yes or no? Right? So if you see this, we will get pH is equal to 7. Got it? That's why pH of neutral neutral solution or neutral water is 7. Okay, right? Then what if we use the whole expression, right? And take pH, take log. Let's see this. Let's see this. We have concentration of H plus into concentration of OH minus is equal to 10 to the power minus 14. Okay, now let's take log to both sides. Okay, take log to both sides. Take log to both sides. Both side. Now let's see what happens. Let's see. So we will get this log concentration of H plus into concentration of OH minus is equal to minus 14. Yes or no? Log base 10, obviously. We have taken log base 10. Yes or no? Yes, right? Because we know that log 10 to the power minus 14 base 10 is equal to minus 14. Okay, now take minus to both sides, or you just take minus and use the property of log. So log A into B is equal to log A plus log B. Okay, now put minus inside. So minus log concentration of H plus minus log concentration of OH minus, right? Can you see that? Can you see what is minus log concentration of H plus? Tell me, what is minus log concentration of H plus? Tell me everyone. Message. What is minus log concentration of H plus? What it is called? What it is called? Yes, very good. This is called as pH. Okay, so I can say that this is pH plus. And what is this called? Minus log concentration of OH minus. Tell me everyone, what is this called? Quick. Yes, very good. This is called as POH. Very good. And this is equal to 14. Got it? Means for any solution, right? Sum of pH plus POH should be 14. Okay, everyone? Tell me, yes or no? Yes or no? Yes, everyone know that? Everyone agree? Okay, just raise your hand. Very good. Samya, Riya, Chulika, Soumya, Aksha, very good. Vivek, Nishita, Pradyumna, Obas, Srihari, Sania, everyone is getting this? Now conceptually, are you finding this comparatively easy? Conceptually, are you getting it? Yes, very good, very good. Now, I have two expressions, right? I have two expressions which I should remember. First expression is this, right? First is this, right? Let me choose red color. Okay, first is this expression, right? This expression. Okay, what is about second one? Second one, right? Second one is this, concentration of OH minus into concentration of H plus is equal to 10 to the power minus 14. So these two expressions we will be using to solve problems. Okay, got it everyone? These two we will be using to solve problems. Right? Now you should ask, so how we will be using these two to solve problems? So let's see everyone. Concentration of, like, we have POH, right? Let's see, we have a POH is equal to what? We have just derived the formula, no? Half, tell me, P Kb minus log C. Yes, for weak monobasic acid, for weak monobasic, sorry, monoacidic base. My bad. Okay, so weak monoacidic base, for weak base, just write weak base. Okay, weak base, right? But you want to find pH, what you have to tell me, what you have to do, right? We know that pH is this. So what is pH? pH will nothing but it will be 14 minus pH. Yes or no? Tell me. Agree? Right, everyone? Agree? Yes? Okay. So sometimes when you think, sir, it is asked to find pH, but we can't find pH, we have pOH, then what you have to do, you just have to use this formula, right? Just have to use this formula. Okay. Now, in sometimes in some questions, right, you're asked to find pH, but OH minus concentration is given. So how to find H plus concentration? So H plus concentration is nothing but 10 to the power minus 14 by concentration of OH minus. Okay, right? Got it, everyone? Tell me, got it? Okay, so everyone got the concept of weak acid and weak base? Yes or no? An ionic product of water? Clear? So till now you should be clear about three things, right? Weak acid, weak base, and ionic product of water. As simple as that, right? Okay, so shall we solve some problems? Okay, okay. We will solve some problems. But before that, let's have some concept test. Okay, let's see how much concept you have understood. Let's have some concept test. Okay, right? Ready, everyone? Think about this. So we have a reaction CO2 plus H2O. Again, H2O, it forms H2CO3, right? Which dissociates into HCO3 minus plus H plus. If CO2 escapes from the system, then what will happen? Think about it. Everyone, think about it. It is a concept of chemical equilibrium, right? Just think about it. Everyone, think about it and message me the answer. Okay, so let's see everyone. The answer is B. pH will increase, right? How so? Right? Most of you said B, right? Let's see this. How so? Because see this, if CO2 escapes, right? If CO2 escapes, okay, so reaction will, obviously reaction will not carry forward, right? Tell me, yes or no, right? Just think about this now, using Lee-Chasles principle, right? Using Lee-Chasles principle, you can say that, right? If, think about this, if CO2 is removed, you have to use Lee-Chasles principle. You are removing the reactant, right? Removing CO2. So reaction will shift in backward direction for H2CO3. Yes or no? Yes or no? This first equilibrium will shift in backward direction. Now, concentration of H2CO3 will be decreased. Yes or no? Just think logically. Concentration of H2CO3 will decrease now. Yes or no? Right? Okay. Then this equilibrium will also be affected. Yes. And this will also shift in backward direction. Yes. Right? Now, if this will shift in backward direction, so obviously concentration of H plus will also decrease. And we know that if concentration of H plus will decrease, pH will increase because it is minus log of concentration of H plus. Okay, everyone, got the concept? Tell me. Yes, raise your hand. If everyone got the concept, just raise your hand. Okay, everyone, very good. Right? Very good, everyone. So everyone understood this concept. Let's see next concept test. See this. Now, this is totally the concept of chemical equilibrium. As simple as that. Right? This is your concept of chemical equilibrium. As simple as that. Tell me. Think about it and tell me. Okay, Karishma? Yeah, I got it. Right? Everyone, please try. So see, right? We know that. What is Kw? I hope everyone remember Kw is equal to concentration of H plus into concentration of OH minus. As simple as that. Right, everyone? Right? Anyone have any issue in this? Tell me, anyone have any issue in this? Now, let's see this, right? Here we have H plus, right? Here we have OH minus. Now, what is this? This NH4 is acid or base? Tell me, this NH4 plus is acid or base? Tell me, think about it. It is acid or base? Yes, very good, Samya, very good. Since it is releasing H plus, it is your acid, right? Now, what about this? NH4 minus, right? NH4 minus. Sorry, NH2 minus. What is this? NH2 minus. What is this? Yes, very good. Because it is accepting H plus, right? It is accepting H plus. So it is base, right? Now think about this. Both will have NH3 as a product, right? So I can say that this is your conjugate acid base pair. Conjugate, wait, my spelling is wrong. Conjugate acid base pair. Acid base pair. Yes or no? Tell me. Yes or no? The conjugate acid base pair, right? NH3, right? NH3. Give NH3, 1H plus, it will form NH4 plus. Remove H from NH3, it will form NH2 minus. Got it? So it is a conjugate acid base pair, right? Now just multiply these two, add these two, right? Add these two reactions, okay? Four plus NH4 2 minus, sorry, NH2 2 minus plus H2O gives what? Gives NH3 plus H plus NH3 plus OH minus, right? Right, everyone? Okay, so this is enough hint. Now tell me what is the answer? Think about it. Now that's a misconception, Akshay. What I said, right? But just think about it. Okay, I said NH3, right? NH3 can give H plus and form NH2 minus. NH3 can take H plus and form NH4 plus, right? So NH3, NH4 plus or NH3, NH2 minus, right? These two are related. Okay, think about it, yes or no? And when I added these two, NH3 was not getting cancelled, neither NH4 plus nor NH2 minus. Yes or no? Right? So let's rephrase my problem, right? Let's see. If I would have something like this, NH3 plus H plus, right? Or plus H2O gives NH4 plus OH minus, right? And NH4 plus gives H plus NH3, right? Now these two are your acid base pair, okay? These your conjugate acid base pair. Got it? Right? Got it? Yes or no? Right? So obviously this and this, right? NH4 plus and NH2 minus, they are not acid base pair, but NH4 plus and NH3, right, are one acid base pair. And again NH3, right, gives NH2 minus plus H plus, okay, right? And NH2 minus plus H2O gives NH3 plus OH minus. This is your acid base pair, conjugate acid base pair. Tell me, yes or no? Yes or no? Tell me, everyone. Because when we talk about conjugate acid base pair, right? So after losing one H plus or after gaining one H plus, it should convert into corresponding acid or base. Yes or no? But think about this, right? Think about this. When I said we will use the concept of conjugate acid base pair. So NH4 plus, right? If you're removing one H plus from NH4 plus, it is forming NH3. It is not forming NH2 minus. Yes or no? Tell me yes or no. Right? So I can say that these are two different, these two reactions are conjugate acid base pair, but therefore different conjugate acid base pair. Okay? Right, everyone? They are two different conjugate acid base pair. Everyone have any issues? Tell me. Now, tell me what should be the answer. Tell me what should be the answer now. Tell me, everyone. Because it's not your conjugate acid base pair, right? And H3 is not cancelled, right? Or H2 minus is not cancelled, and H3 is not cancelled, right? So you're not getting anything. So answer should be D. Yes or no? Answer should be D, right? Because I gave you a hint by adding these two reactions, right? NH3, NH4 plus and H2 minus was not getting cancelled now, right? So the answer should be D. Okay, everyone? Tell me. Let's see. Yes, it is D, right? To see this, everyone, please focus and try to understand the concept. Okay. Okay, everyone. Okay, everyone. Right? Okay. So let's see. So see this. So when we talk about the concept in 8.1, right? Let's see what are the concepts that we have already covered in 8.1. Okay. The concept that we have covered in 8.1. So electrolyte, non-electrolyte, yes, covered. Right? Then strong electrolyte, yes, covered. Classification of acid and base using following: Bronsted-Lowry, yes. Yes. Lewis, no. Right? But we have covered Lewis in chemical bonding. Conjugate acid base pair, yes. Ionization of water, yes. Relationship of acidity and basicity, right? Yes. pH scale, yes. Right? Okay. Right. So we have covered 8.1. Now I hope all of you remember the concept of Lewis theory. What is Lewis acid? What is Lewis base? Right? Now, when we talk about Arrhenius, it was H plus and OH minus, right? When we talk about Bronsted-Lowry, it was just H plus. If you remove H plus, it will be acid. If you gain H plus, it will be base. Okay, right? Now, ultimately, you should remember acid is poor, right? And base is rich in terms of electrons, okay. Now if acid is poor, right, so it will try to accept electron, it will try to give electron. Tell me everyone. This is one thing that you should remember always, right? This is just like a mnemonics. You can remember acid is always poor, right? Accept, yes. So electron accept, okay, right? So any electron deficient species, electron deficient compound is your Lewis acid. Okay. What about base? It is electron donor. Electron donor. Okay. Got it? So I can say that any electron rich species, right, will be your Lewis base. Okay, everyone. Got it? That's the concept. Easy to understand, right? Let's see some example, right? Okay, let's see example of AlCl3. Now when we talk about AlCl3, Al will have vacant p atomic orbital, right? Okay, vacant atomic orbital. right? So it is electron deficient. Okay, so it is your acid or base? Tell me, it is Lewis acid or Lewis base? Yes, very good, Lewis acid. Okay. Anyways, the concept of Lewis acid and Lewis base will not be used in this chapter. It will be used for mainly organic or chemical bonding. Okay. We will be focused on Arrhenius concept and Bronsted-Lowry concept. Right? Okay. So from NCERT, you have to read till this section, till section 7.2. Right? Yes, Karishma, you remember? We have used this concept. Okay. So these are the concept of Arrhenius theory we have already discussed, right? Arrhenius theory, right? According to Arrhenius theory, if a substance, right? If a substance give H plus, right? It is your acid. If it gives OH minus, it is your base. Whereas in Bronsted-Lowry, it is your protonic concept, which means you don't need OH minus to be a base. It's just if you releases H plus, if you donate H plus, you are acid. And if you're accepting H plus, then you are base. Okay. Then Lewis concept, depending on the electron or lone pair, right? Okay. Now, conjugate acid base, we have already studied. Ionic product of water, we have already studied, right? I hope all of you remember these concepts which we studied today. Okay, now let's solve problems one by one. Okay, let's see, right? Let's discuss this illustrations anyways. The first illustration, in the reaction BeF2, 2F minus form BeF4, 2 minus. Right? Now tell me, in these two, which is Lewis acid, which is Lewis base? Without seeing the solution, just think BeF2, right? 2F minus. So you can just see that 2F minus, this F have electron, yes or no, right? So obviously it is electron rich. It is electron rich. And BeF2, we know that BeF2 is electron deficient. How come? How can you say that? Sir, because the octet is not complete. It is contracted octet. Yes or no? Contracted octet. Right? Be is only having 2 bonds. So this is electron deficient, poor. Right? So this is your Lewis acid and this is your Lewis base. Got it, everyone? Tell me, got it? Yes? Okay, very good. Now, question number 2. Write the conjugate acid-base pair. So let's see this, HCN. HCN will give what? See, H plus and Cn minus. Right? So obviously, Cn minus is the conjugate base of HCN. In the same way, N2H5, C2H5OH, right? Right? If it is removing H plus, it is your conjugate base, as simple as that. Okay? Got it, everyone? Now, everyone should solve question number 3. Okay? Everyone should solve question number 3. Right? Think about question number 3. Everyone, think about question number 3. So the pH of 3 into 0.3 into 10 power minus 3 molar COH ka whole twice. Now, what question I told you? What question you have to ask by yourself? So this is your strong electrolyte or weak electrolyte. So tell me, CaOH ka whole twice, strong or weak? It is written that it is strong, which means CaOH whole twice will be broken down into Ca2 plus 2OH minus. Agree, everyone? Agree? Tell me, agree? Anyone have any issues? So if concentration of CaOH per whole twice is A, right? 0, 0. So after reaction is completed, it will be 0, it will be A, it will be 2A. Any issues in this? Because it is not your Reversible reaction. It is your irreversible reaction. Right, everyone? Tell me, right? Yes? Raise the hand. If you think that it is right, raise the hand. Because it is your strong electrolyte, it will dissociate completely. And we just have to use the concept of mole concept, right? Very good. So tell me, what is the concentration of OH minus? Concentration of OH minus. Tell me. Wait. Yeah, tell me. Concentration of OH minus. Tell me. It was given as, it is given as what? It is 2 into concentration of COH का whole twice. Yes or no? Tell me, yes or no? And we know that the concentration of COH का whole twice was 0.3 into 10 power minus 3 molar, right? 0.3 to the power minus 3 molar. Yes. So concentration of OH minus, as simple as that. No concept of equilibrium will be used. 2 into 0.3 into 10 to the power minus 3 molar. Yes. Anyone have any issues? Tell me, anyone have any issues? But you have to find what? You have to find pH. You have to find pH. So you should get what is the concentration of H plus. Now, how can we get the concentration of H plus? Tell me, how? Anyone remember? I just discussed this in today's class. Tell me, I just discussed this in today's class. Yes, very good, Oves, right? So we discussed now that if you have concentration of OH minus, no Ria, it is strong acid. See, that's the first thing that you have to think. Strong acid. We cannot use the formulas or concept of equilibrium for strong acid, right? And this is a normal concept for strong acid, right? It is will dissociate completely, but we have this formula whereby concentration of OH minus. Yes or no? Tell me. Yes or no? Yes or no? This, right? That concentration of H plus is always 10 power minus 14 into concentration divided by concentration of OH minus. So I can say that concentration of H plus is equal to 10 to the power minus 14 divided by 0.6 into 10 to the power minus 3. Right? Right, everyone? Which is 10 by 6 into 10 to the power minus 11. Right? So this is, tell me, this is what? 5 by 3 into 10 power minus 11. This is concentration of H plus. Then you can find pH. Yes? Right, everyone? Okay, let's see. Okay, say this. Okay, right? Same thing is being done because it is your non-reversible reaction, irreversible reaction, right? Concentration of OH minus is twice of concentration of this POH. You can just calculate POH and subtract it with 14, or you can just calculate concentration of H plus and then find the value. You can do anything, it's same. Okay, got it, everyone? Now next, question number 4, right? Everyone try solving question number 4. Okay, See, 4 at the bottom of the screen. The pH of a mixture of 100 milliliter of 0.1 molar HCl. So we have, see, these kind of questions can be solved just using mole concept. Okay, right? No equilibrium concept is used here. Okay, no equilibrium concept is used over here. Now just think about this, right? I'll give you 2 minutes. Everyone, you have 2 minutes. Think and try to solve. Okay, let's see this problem. Everyone, let's see this problem. Okay, now what do we have here, right? Now just think about that. Just think about this. This is your concept of mole concept. Okay, right? 100 milliliter of 0.1 molar HCl. So HCl will give what? Tell me, HCl will give what? H plus, right? HCl will give H plus, yes or no? Yes or no? HCl will give H plus, yes. 1 mole HCl will give 1 mole H plus. Okay? And how many moles of HCl we will have? 100 milliliter into 0.1. So it is 10 millimole. 10 millimole of HCl will give 10 millimole. 10 millimole of HCl will give 10 millimole of H plus. Anyone have any issue till this point? No? In the same way, H2SO4 will give what? 2H plus SO4 2 minus, right? So 1 mole of H2SO4 will give 2 mole of H plus, right? Now how many millimoles of H2SO4 we have here? So 300 into 0.1, which is 30. So 30 millimoles of H2SO4 will give 60 millimoles of H plus. Any issues? Tell me, any issues till this point? Yes or no? Right? So H plus total H plus is what? Tell me. It is 10 plus 60, 70 millimoles. Okay. Now I should rub this. In the same way, we have BOH per whole twice. So BaOH whole twice will give you what? Ba2 plus 2OH minus. Means 1 mole of BOH gives 2 mole of OH minus. So it is how many moles? 0.3 into 100, right? Which is 30. So this will be 60. Okay. Now 60 mole of OH minus is there. So we have H plus, forget about everything else. H plus 70 millimoles. OH minus 60 millimoles. What will happen? Tell me, what will happen? Tell me, what will happen? They will neutralize each other and form H2O. Yes or no? Yes or no? Agree everyone? Raise your hand. If you agree, raise your hand. Are you getting this concept? The H plus from strong acid will neutralize OH minus from strong base. Okay, out of two, which is your limiting reagent? Tell me, out of these two, out of H plus and OH minus, what is your limiting reagent? Yes, very good. OH minus, right? So after the reaction, right? After the reaction, after the reaction, right? You're left with 10 millimoles H plus, 0, and this will be 60, doesn't matter, it's water. Okay, so you are left with 10 millimoles of H plus. So what will be new concentration of H plus in overall reaction, right? Number of millimoles of H plus is 10 millimoles. What about total volume? Tell me, what is total volume? 100 plus 300 plus 100. It is, tell me, 500. But see, 1 liter. So this is 1 also, right? 1 liter, right? Got it? Got it, everyone? So concentration of H plus is 10 millimoles, which is 10 power minus 3, right? Molar. Yes or no? 10 to the minus 3 molar. Agree? Agree, everyone? Because see, volume, it is said that it is 1 liter, right? So 10 millimoles, which is 10 to the minus 3 moles by 1. So it is 10 minus 3 molar. So what is pH? pH is nothing but power of 10. pH is nothing but power of 10. So pH is 3. Got it, everyone? pH is 3. Wait, I made some mistake or what? Okay, sorry, it is 10 now. Sorry, it is 10 to the minus 2. My bad. It is 10 to the minus 2. Yes. Because it is 10 now, 10 into 10 to the minus 3. 10 to the minus 2. So pH is 2. Okay, right? Now, you can use this shortcut also. If you observe whole process, it is thus this. Total concentration of H plus is equal to M1V1, M1V1, this is M1, sorry, this is V1, this is M1, M1V1 plus M2V2, but here it is diabasic, so it is 2 into M2V2. This is minus because it is OH minus 2 into M3V3 divided by V total, right? This is your moles of H plus total divided by volume concentration. Got it? Yes or no? Tell me. Got it, everyone? You don't have to use any concept of equilibrium, right? You just have to use your normal mole concept. Got it, everyone? Tell me yes or no. See this? Okay. Okay, everyone. I hope all of you understood, right? So please try solving 8.1. In next class, we will discuss 8.1, both in class and homework. Okay. Now let's play one Kahoot. It's Kahoot time. So we'll play one Kahoot. Okay. Okay. Right. Please be ready, everyone. We'll play one Kahoot only. The code is 3632271 2217. Sorry. Everyone, please join. Everyone, please join. 3632217. Okay, Chulika, no issues. Try to solve this, everyone. It's super easy, right? Only 28 answers. Yes, HCl, right? HCl. We have discussed now. Very good. Next. Fast, fast. Big electrolyte. If you have observed last question properly, you can answer within seconds. Yes, very good, right? Still many students made mistake. See, NH3 was there in last question, right? NH3 was there now. Okay? NH3 was not your strong electrolyte, so obviously it is weak electrolyte. Okay, next. Conjugate acid of HSO4 minus. Conjugate acid of HSO4 minus. Super easy, tell me. Conjugate acid of HSO4 minus. Okay, I got 29 answers. Let's see how many of them are correct. Okay, 22 are correct. Yes. See, conjugate acid, right, means after removing H plus, you should get this. So just add the H plus to this, you would get the answer. So it is H2SO4. Yes, very good. Meet maintaining the first position. Shulika in fifth position now. Very good. Conjugate base of H3PO4. Very easy. You should answer it within seconds, right? Conjugate base of H3PO4. The faster you answer, more marks you'll get. Okay, everyone? Yes, it is H2PO4 minus, because just remove one H plus, right? Very good. Now Ria is in top 5, Avas first position. See, as soon as you answer, the more marks you'll get. Which of the following is amphiprotic ions? What's the meaning of amphiprotic? Both acid and base, right? I hope all of you remember amphiprotic, both acid and base, okay, which can be both acid and base. This is quite easy. The option itself says the answer, right? Amphiprotic, right? Which is both acid and base. Okay, we have only 7 students got the correct answer. See this. First, I said amphiprotic is that compound which is both acid and base, right? So obviously for being acid, it should have H plus now, right? Concentrated acid should have H plus, right? Now HS, after removing H plus, will give H plus plus S2 minus, right? And after taking H plus, H plus, it forms H2S. Same as OH minus, yes or no, right? Got it, everyone? Same as NH3, OH minus, HS minus, all of them are amphiprotic. Okay, next. At 90 degrees centigrade, pure water has concentration of H plus as 10 to the minus 6. Concentration of H plus, because when you talk about H3O plus, it is H plus, okay? Yes, I hope all of you remember when you talk about 10 to the minus 6, concentration of H3O plus is 10 to the minus 6. What is the value of Kw at 90 degrees centigrade? It's easy, super easy, tell me. Tell me, everyone, you should get this. So here temperatures change, so obviously K will change. Yes, very good. So most of you said, see, we know that, right? Concentration of H plus, right, squared is equal to Kw. That's it, right? For pure substance, pure water. So pure water, right? Right, everyone? So 10 to the minus 6 whole square is equal to 10 to the minus 12 now. Okay? Next. pH of 10 to the minus 8 molar HCl solution. This is a very good question. We will discuss it in the next class. But for now, what do you think? What's the answer? Let's see. This is a very good question. We will discuss this in next class. Right? Yes, Abhiram, we did this in last year, 10th class, we did it. Right? If foundation students remember. But anyways, let's see logically what should be the answer. Yes, Ovas, very good. So I hope at least you two remember. Anyone else remember from the foundation? Yes, Aryan, you also remember, very good. Yes, Malik, right? Yes, answer 6.98. Okay, so I guess most of the foundation students remember, very good. Now we will discuss why it will be 6.98 in next class. Okay, let's see. Okay, remember this, we will discuss this, right, in next class, which is tomorrow. If temperatures increase, the pH of water will, tell me. We just saw that. Refer question number 7. If temperature increases, K decreases or increases? Right? Think like that. Let's see how many of you got it correctly. 15 strengths, yes. See, in last question, right? In last question, we have discussed now, right? If temperature was 90 degree, right? Concentration of H plus was temper minus 6, which means pH was 6, right? But at normal temperature, pH was 7. So obviously decrease, right? pH decreases. Got it? So it should be less than 7. Okay? If you have focused on the last question, right, you could have answered it correctly. Okay, let's see. Najashan in top 10. Anisha, second position. Very good, Anisha. TKW of water at 25 degrees centigrade. Super easy question. Should be answered within seconds. This should be answered within seconds at 25 degrees centigrade, which is normal room temperature. What's the answer? This should be no-brainer. Yes, very good, very good. 19 answers till now, 21 answers, 23 answers till now. Everyone, please message, please vote. Only 15 seconds left. 25 answers till now. Last 10 seconds left. Yes, this is 14 now, 14, right? We have studied at room temperature. It is 14. Okay? No change in order. There's a huge difference in score now. Last question, let's see. 10 to the minus 2 moles of KOH is dissolved in 10 liters of water. The pH of the solution is, think about it. pH of the solution is super easy. Okay, let's see everyone. The answer, right? Because C, right? Very good everyone. So if you see this, right, it is KOH. So concentration of OH minus is equal to what? 10 to the minus 2 by 10, which is equal to 10 to the minus 3, right? So POH is equal to 3. We know that pH is equal to 14 minus POH, which is 14 minus 3, which is 11. Got it, everyone? Right? Got it? Okay, let's see the podium. Third position, Abhiram. Very good, Abhiram. Congratulations. Second position, Anisha. Congratulations, Anisha. First position, Ovas, very good Ovas. And let's see who are runner-ups. Srihari and Jasharan. Very good everyone, right? So tomorrow we will discuss 8.1, okay, right? Yeah, 12 selected, 12, 11 selected, 11. Okay, okay everyone, thank you everyone, right? So we will just, in today's class,